number 1 from our triangle sum and exterior angles worksheet. So, if angle 4 is 75 degrees and angle 2 is 40 degrees, find the measure of angle 5. If y'all remember, we learned a shortcut theorem. I called it a shortcut theorem, and it says the sum of the remote interior angles equals the exterior angle. So you actually add these two puppies up, and it equals that one. 40 plus x equals 75. So this is really just a problem of 75 minus 40. Okay, on that one? So we would get, our answer would be 35. Okay, the next one I was asked about, number 4. Number 4 says, if angle 6 is 150 and angle 2 equals angle 3, so I'm going to call it x and x because they're equal, they're identical, then find the measure of angle 2. This is also good use of the remote interior angle theorem. Those are remote interior angles. These add up to equal our exterior angle. So it's x plus x equals 150. So it's 2x equals 150. So it's x equals 75. All right, next one, number 12. Find the value of x. All right, so we have a little bit of information here. We've got an angle of 20. We've got an angle of 80. For this worksheet, all we're using are the angles of a triangle add up to 180, and we're using our remote interior angle theorem. So those are the two things we're using. You got to get a little bit crafty on this one. Take a look at this triangle. You see that blue triangle? 20 and x are the remote interior angles. And 80 is our exterior angle. So we're really ignoring this line right here. It was kind of there to trick us. So we're going to add up 20 plus x, and it's going to equal 80. So it's going to give us 60 for x. That better on that one? So you're looking for what can I use with the theorems that I was taught. All right, next one, that was 12, moving on to 15. Wait for the numbers to show up. There we go, there's our numbers. All right, 15, we're looking for angle x. It's weird. It looks like x is pointing to like that segment, doesn't it? So we know that if this is 90, this one has to also be 90. So we could do 90 minus 63. So that'd be 27. So we really didn't use that other 27 at all. That one's kind of weird. We just used a right triangle for that one. All right, 15, 17. If the measure of the exterior angles of the acute angles of a right triangle are that and that, find the measures of the acute angles. Oh, this showed up on a quiz, didn't it? Okay, keyword, exterior. So we've got a right triangle, and we've got an exterior angle, and we've got an exterior angle, and we know this other exterior angle is 90, and we're trying to find the measures of these two angles. Okay? Now, if we hadn't learned the polygon lesson yet, we wouldn't know to add those three to equal 360. But we've learned the polygon lesson, so we know that 90 plus 3x minus 5 plus 2x plus 15 equals 360. Because we know the exterior angles of any polygon add up to 360. So we would solve that, and what would we get for x? Let's see. X is 52. Yep, perfect. Okay. So x is 52, so now we're going to plug it back in. 2 times 52 plus 15, 119. And 3 times 52 minus 5, 151. So now we're finding the linear pair of 119, 61. And we're finding the linear pair of 151, 29. So the answers were 61 and 29. All right, number 20, last one. Okay, the measure of the angles of a triangle are x, x, and 4/3 x. If the largest angle is doubled and the triangle remains isosceles, how would you represent the measures of the angles in the new triangle? Okay, let's capture this. Which angle is the largest angle, by the way? Which angle would be the largest angle? Yeah, the 4/3. Okay, so if we've got x, x, and 4/3 x, if we're going to double the 4/3, 4/3 x would become 8/3 x. If we're going to double the 4/3, we have to kind of like make up for it by halving our other two angles. Does that make sense? We have to kind of like compensate for doubling that vertex angle because we want to make sure that we're still isosceles. Okay, so what did these add up to before? So we've got x plus 4/3 x. So we've got 3/3 plus 3/3 plus 4/3. So 4, I'm going to write this as 3/3. 4, 5, 6, 7, 8, 9, 10. 10/3 x. Okay, that's what it added up to before. Now, we've got 8/3 x, and we need to know what goes with it. Well, we need it to stay isosceles, and we need it to equal 10/3 x. So what would be our new numerator? 8 plus something equals 10, and they have to be even. They have to be the same. So 1/3 and 1/3. Now it adds up. 8 plus 1 is 10, and so it still adds up to 10/3 x. We kept our same ratio, but we doubled our largest angle. I hope that makes sense. So that's how we get, this was our final answer. 8/3 x, 1/3 x, 1/3 x. All right, let's get into